This is a video from section 3.11. We're going to look at the definition of the hyperbolic functions. First, sinh x is equal to e to the x minus e to the negative x divided by 2. So that's how you say that, by the way. SINHX is sinh x. Or another way to say it is hyperbolic sine of x. Okay. Cos x, or hyperbolic cosine x, is e to the x plus e to the negative x divided by 2. Hyperbolic tangent x is sinh x over cos x. Hyperbolic cosecant x is 1 over sinh x. Hyperbolic secant x is 1 over cos x. And then hyperbolic cotangent x is equal to cos x divided by sinh x. Now, the directions say to find the numerical value of each expression. And we're going to use the definitions given on the previous page. Okay? Let's start with 1a. So we're going to look at sinh of 0. But that's e to the 0 minus e to the negative 0 divided by 2. So all I do is replace x with 0. And so here I get 1 minus 1 over 2, which is equal to 0. So sinh of 0 is 0. 1b, suppose I want cos of 0. Well, that's e to the 0 plus e to the negative 0 divided by 2, which is 1 plus 1 over 2, which is equal to 1. Now, on 2a, suppose I want hyperbolic tangent of 0, but that's hyperbolic sine of 0 or sinh 0, either way, divided by cos of 0. Well, we just figured out that sinh of 0 is 0 and cos of 0 is 1. So this is 0 divided by 1. The answer is 0. 2b. Suppose I want hyperbolic tangent of 1. Well, this is going to be sinh of 1 divided by cos of 1. Now, we have to figure out what both of those are. Okay. Now, sinh of 1 is equal to e to the first minus e to the negative 1 divided by 2. Cos of 1 is e to the 1 plus e to the negative 1 divided by 2. And so this is e to the first minus e to the negative 1 divided by. Now, notice how the 2's are going to cancel. And so what you'll end up dividing by is e to the first plus e to the negative 1. And then what I'm going to do is I'm going to multiply the numerator and denominator by e. And when I do that, I get the following. I get hyperbolic tangent of 1 is e squared minus 1 divided by e squared plus 1. And that's 2b. 3a, Suppose I want cosh of natural log of 5. But that's e to the natural log of 5 plus e to the negative natural log of 5 divided by 2. But this is e to the natural log of 5 plus e to the natural log of 5 raised to the negative 1 divided by 2. And so, therefore, cosh of natural log of 5 is 5 plus 5 to the negative 1 divided by 2. And then what I'm going to do is I'm going to multiply the numerator and denominator by 5. And you might ask why. Well, that gets rid of the negative exponent that we are seeing in the numerator. And when you end up doing that, you get the following. You get cosh of natural log of 5 is 25 plus 1 divided by 10, which is 26 over 10. And if I divide the numerator and denominator both by 2, I get cosh of natural log of 5 is 13 divided by 5. Okay. And then I hope that came in clear. Let me rewrite that up here. So here it's e to the natural log of 5 plus e to the natural log of 5 raised to the negative 1. And this is all divided by 2. And then the rest of this will follow. That's 3a. 3b. Cosh of 5 is e to the 5 plus e to the negative 5 divided by 2. And again, I'm going to multiply numerator and denominator by e to the 5. And when that happens, I get cosh of 5 is the same as e to the 10th plus 1 divided by 2e to the 5th. If we take a look at 4a, suppose I want sinh of 4, but that's e to the 4th minus e to the negative 4 divided by 2. And I'm going to multiply numerator and denominator by e to the 4th. And when that happens, I get sinh of 4 is, now e to the 4th times e to the 4th is e to the 8th. So I get e to the 8th minus 1 divided by 2e to the 4th. And that's 4a. If we take a look at 4b, suppose I get sinh of natural log of 4, but that's e to the natural log of 4 minus e to the negative natural log of 4 divided by 2. But this is e to the natural log of 4 minus e to the natural log of 4 raised to the negative 1 divided by 2, which is 4 minus 4 to the negative 1 divided by 2. And what I'm going to do is multiply the numerator and denominator by 4, and that's going to clear out that negative exponent. And so what we end up getting is sinh of natural log of 4 is 16 minus 1 divided by 8, which is 15 over 8. Let's take a look at 5a. Suppose hyperbolic secant of 0. We want to figure out what that is. But that's 1 over hyperbolic cosine of 0. Now, we don't have to do a lot of work here, because if we go back, we figured out what hyperbolic cosine of 0 was. Hyperbolic cosine of 0 is 1. So if we go back here, we get 1 over 1, which is 1. That's it. And let's take a look at 5b. Now, suppose we want inverse hyperbolic cosine of 1. Here's how I'm going to attack this problem. I'm going to set y equal to inverse hyperbolic cosine of 1. Okay? And this says that hyperbolic cosine of y is the same as 1, and y is greater than or equal to 0. So we need that extra condition that y is greater than or equal to 0. Now, this says e to the y plus e to the negative y divided by 2 is equal to 1, like so. So e to the y plus e to the negative y is the same as 2. And I'm going to multiply both sides by e to the y. So I get e to the 2y plus 1 is the same as 2e to the y. So that says e to the 2y minus 2e to the y plus 1 equals 0. Okay? So that says e to the y minus 1 to the second is equal to 0, which says e to the y equals 1, which says y equals 0. That's the only way you're going to get 1. But if we go back, y is equal to the inverse hyperbolic cosine of 1. And so, therefore, the inverse hyperbolic cosine of 1 ends up being 0. So it's a nice little way to reason that out. If we take a look at 6a, suppose we want hyperbolic sine of 1. But this is e to the first minus e to the negative 1 divided by 2. And I'm going to multiply numerator and denominator by e. And so, therefore, hyperbolic sine of 1 is the same as e squared minus 1 divided by 2e. That's it. And if we want on 6b, suppose we want inverse hyperbolic sine of 1. Okay, so the way, again, that I'm going to do this is I'm going to set y equal to the inverse hyperbolic sine of 1. And so this says 1 equals hyperbolic sine of y. So 1 is e to the y minus e to the negative y divided by 2. So e to the y minus e to the negative y is the same as 2. And I'm going to multiply both sides by e to the y. And so e to the 2y minus 1 is 2e to the y. So e to the 2y minus 2e to the y minus 1 is 0. So if I apply the quadratic formula, I get e to the y is 2 plus or minus the square root of b squared, which is 4, minus 4 times 1 times negative 1 divided by 2. So e to the y is 2 plus or minus the square root of 8 divided by 2. And so e to the y is 2 plus or minus 2 square root of 2 divided by 2. And so either e to the y is 1 plus the square root of 2, or e to the y is 1 minus the square root of 2. Because keep in mind, I could factor out a 2 from the numerator and get 1 plus or minus the square root of 2 divided by 2. But the 2's cancel, and you get 1 plus or minus the square root of 2. Okay? I hope that makes sense. Now, remember here, I'm going to put a note up here. E to the y is positive the whole time, the whole entire time. So I claim this can't happen because remember 1 minus square root of 2 is strictly less than 0. And so that says e to the y is 1 plus the square root of 2. But that says y is natural log of 1 plus the square root of 2. But remember y is equal to, let's go back, the inverse hyperbolic sine of 1. Okay? And so therefore, the inverse hyperbolic sine of 1 is natural log of 1 plus the square root of 2. And that's going to conclude this video for section 3.11, where we did problems 1 through 6. Thank you.